Saxon Algebra 1, Lesson 79. Our topic today is subscripted variables. That sounds so hard, doesn't it? But it's really easy. It's a stylistic idea that we're going to drop on you. Normally we have variables like X and Y. Sometimes we might have an uppercase letter like R or T. These are variables, okay? Now, you know that. They can be any letter you want. You can have two of them together if you want, right? But sometimes in the problems we're going to be working in the future, so future you is going to do this, we might want to have variables with these little letters down below. Now, I'm not going to be coy. I'm going to tell you exactly the story that's going to make these really useful. We're going to be doing problems that involve rates and times. And there will be different people, like let's say Annabelle and Maria, just for fun. We talk about the rate of Annabelle and the time of Annabelle, and then the rate of Maria and the time of Maria. It's so much easier if we can make the variables match to the words in the story, rather than just giving them, random letters like X and Y. So we use this little method of writing not two big letters, but a little letter down below. It doesn't change the math. It just helps the variable fit with the story a little bit better. All right, so these are what are called subscripted variables down here. These are just regular variables. We use them exactly the same. They just look different, okay? So don't let those freak you out. It just makes you smart. In these problems, what we're going to do is we're going to practice doing the solving for some of these types of algebra problems, types of equations we're going to set up when we get to this rate and time thing, all right? So right now we're just learning how to do the math. All right. So John says, solve the following system of equations for RA. Okay, so you can always assume the R's are rates and the T stands for time. All right. So we're going to be solving for the rate of somebody whose first name starts with an A, probably, right? Okay, this is what John gives us. No, I don't want to do this. I want to write them over here. John writes them across the page, but I can never get them to fit, and then it just gets confusing. So I write them down. John writes them across. I don't want to scramble them all up for you. That's why I scribbled it out. Okay, what you'll notice is that first equation that I wrote down, that is crazy, isn't it? It's got 4 different variables in it. The other 3 equations are pretty simple. They're just a certain variable equals a number. These look easy. This is what's called a base equation. The base equation means it's the one with the most variables, and we're going to plug other variables into that base equation so that we can solve. All right? It's a general strategy that we'll use really often, and sometimes we'll have to think a little bit before we choose our base equation. This one is easy. It's just the ones with all the letters in it, all right? And that's also very helpful because basically I'm writing then down a list of things we're going to plug in. So what I'm going to do is I'm going to rewrite this, only for every variable, I'm going to put a bucket. Right? RA, TA, RP, TP. I'm adding them together. They equal 320. So that's the next step. So number 1, find your base equation. Number 2, set up buckets. Okay? 3, fill in. RA, oh, that's the one we don't know, so we just have to settle for the letters. TA, 3. RP, 50. TP 4, and we're good. Now we simply solve. So I like to see the number in front of the letter, and I bet you do too. 3RA plus, that's 200, equals 320. Subtract 200, right? We're just swimming some fish here. NBD, 3RA, that's gone, equals 120. Oh. So we get the rate of whoever the A person is equals 40. And that's our answer. But that's not so bad, is it? Right? Find your base equation, set up the buckets, fill them in. Let's write them down. These are the steps. Again, the base equation is the one with all the options, and it's what you're going to plug everything else into. 2 write out the base with buckets. You know, I call parentheses buckets. And then the third one, fill in the buckets and solve. 1, 2, 3. It's as easy as that, you guys. What could be more fun? Let's do another one. How many are there? There are 4. Okay, ready? Next page. One of my worst nightmares is that I flip the page over, but I don't check my camera to make sure it's still in screen. And like I do something like this, which is actually kind of impossible, but like that. And I end up finishing the lesson out of camera, and you guys are sitting there. I mean, I know what you'd be doing. You'd be crying, gnashing your teeth, wailing, ripping your clothes, because you'd be so upset that you were missing the math. Solve the following system of equations for TB and TR. No, I read that wrong. T, R, and T, T. Remember, these don't have anything to do with the calculations. They're not like exponents. They're just stylistic designations. Okay, here we go. And here come the easy ones. Okay, well, that was really messy the way I wrote it. So clearly this is our base equation. We're going to plug these things in. So let's start by writing this with buckets. This one is a little bit different, the way the number is, right? Last one, these two chunks, we added them together, and then they added up to 320. This time we're taking one of the chunks and adding a number, and that's equal to the other chunk. Weird. Okay, but it's fine. This will all make sense someday. Okay, RT is 2. That goes there. Our R is 10. That's an equal sign. That goes there, right? I'm just referring to this to figure out what goes where. TR equals TT. Okay, tip here. If the T's are the same, drop the subscript. What I mean by that is, if the T's are the same, then there's no need to distinguish between them. So I'm just going to put that for both of them, right? I don't need that subscript causing me drama and strife if it's not even necessary. They're the same. So I make life easier on myself and I just drop it. You could make them both TT or you could make them both TR. That's fine, but you can just drop it all together and life is so much simpler. Okay, 2T plus 120 equals 10t. I think I'm going to subtract 2t. And I'm going to get 120 equals 8t. And I'm going to divide by 8. And I'm going to get t equals, let's see, 10 times is 80. It's 15, isn't it? That's correct. Now, because both t's are this, we're supposed to solve for tr and tt. I'm going to write it like this. I guess I'd write, I don't want it to look like and. tr and tt are both 15. Okay, I could write them separately. I could have written it like this. That's probably the best. Yay. Lovely, right? Gosh, how could this be any more fun? I know when I give you the story that you have to figure out before you figure out all these equations. Eventually, you're going to get a story and you're going to be able to write out the equations like this and then do the solving. The nice part will be you'll be already used to doing all the solving part before you get the story. John's really cool about doing that so that you get comfortable with the math part of it, well, the solving part before you have to set it up. Okay, same thing. This time we're solving for TL and TS. Okay, I have a problem. I mean, kind of. S's are treacherous because an S looks a lot like a 5. So when I have S's in my problems, I do two things. I work really hard to make my 5s straighter and squarer, and I often do this. I put a little loopy tail on the end of my S so that it looks like something different than a 5. All right, ready? Here come our equations. Okay. The subscripts are the only place where the S, the letter S shows up. This is the only 5, okay? So if you see the little subscript, you know that's an S. There's no 5s in the subscript. Okay, number 1, choose your base equation. John usually puts it first. It's easy. 2 things multiplied equal 2 things multiplied. So this is a third kind of format, isn't it? Our L is 40. TL, we don't know. Now this time we're not told that they're the same, so we can't drop the subscript like we did last time. TS is 80, or RS is 80, sorry, I said that wrong. TS is this whole thing, so we're just going to put all of that in here. Make sense? It's okay to put an expression in as one of the values. That's fine. Okay, now let's remember here we've got basically a binomial, right? So we're going to have to distribute that 80 across. So this is going to be 40 times TL equals 80 times TL minus 5 times 8 is 40 plus another 0, 400. What? All right, well, we're going to have to deal with some negative numbers, but that's fine. It's not hard, it's just don't get confused. Let's swim the 80 TL this way. That's gone. 40 minus 80 is minus 40. TL equals minus 400. Oh, well, at least he was nice about that. We could have avoided the negative numbers by swimming everything, but or close to everything. But that's, you know, I don't want to say I'm lazy, but I'm not looking to make this harder than it needs to be. You know what I'm saying? So we can handle the negative numbers. That goes away, and what we get here is TL equals, those minuses cancel, those two zeros cancel, so it's 10. TL equals 10. Now we go back over here and we say TS equals, now we can plug this in, 10 minus 5, so TS equals 5. And TL equals 10. That was the two things we were supposed to find, right? Let's check and make sure they're right. TL equals 10. TS equals 5. Yay! Feels so good when you get them right, right? Okay, one more. And it's so annoying when you get them wrong. Am I right? You're just like, ugh, why? Why is my life what it is? I understand. One more. Example 79.4. Solve the following systems of equations for RF and RE. And these are very true to the problems we'll be doing later, where he can ask you to solve for all kinds of different things. It's one of these problems is slightly different, which is what makes them ever so fun. It's really easy to tell which one is the base equation because it's the one that takes you the longest to write. Well, this one's not the shortest, but the base equation is always the long, annoying one. And John, like I said, John is really nice. He almost always puts it first. Okay, so we see here that we have another situation like we did last time, where one of the variables is expressed as another variable plus a number. Last time it was the t's that were like this and the r's were plain numbers. Now he's flipped it around. It's okay. We can handle that. It is, like I said, just kind of annoying when you get further into these problems that they can't just be the same ever. Every single one is drama. Okay, so two things multiplied times two things, right? That's the form here. So there I copied it. TF goes here. So here's where my 16 goes. TE is 12 down at the end. RE equals this. So that goes here. RF plus 15. Don't be like me, kids. Make your boxes bigger when you see that you have one of those, so that you won't have to squish it. Now, we don't have anything for this. That's okay. We just put that letter that showed up in the base equation. Just go ahead and fill that back in, okay? That's always a rule. If you've used everything and you've got a blank, just put in the original one. And now we can see, look, we've got variables in two places, but it's the same variable. Oh, happy day. Look at it for a minute before you immediately start recopying. And I see here, okay, this is two-parter. We're going to have to distribute like this, aren't we? Take a minute and just look at what you're going to be doing. There's no work in this, but I like the number before the letter. So we're going to make that 16 RF equals, and this will be 12 RF plus 15 times 12. I've been a wreck with my basic multiplication today. I've made so many mistakes in the other lessons I've taught that I will take nothing for granted. Plus 180. Make sense? Okay, John agrees with me. Now what? Let's swim this one over. What do you think? That'll leave this number by itself. I like it. That's gone. We get 4 times RF equals 180. And we can divide by 4. Half of 180 is 90. Half of 90 is 45. So I'm going to say our F equals 45. John agrees. And now we take this and we go back here and go, aha, that means that the rate of E equals, let's see, you take the rate of this, and you add 15, so that would be 60. Yay. Okay? Every one of these problems has been a little bit different, but our basic rules hold. Find the base equation, write it out with buckets, fill them in and solve. Okay? This is really great practice, you guys, for you to get comfortable with all of these equations and plugging things in and not letting those subscripted variables freak you out, because they really don't make any difference, do they? They just make your page look more cluttered, and they require that you work a little bit neater so that you can see what the heck you're writing. But otherwise, hey, it's just another day at the beach for you guys. I have no concerns whatsoever. All right, that's the end of 79. Goodbye.